In this lesson, we're going to cover physical and chemical property, physical and chemical change, and classification of matter. The timestamp for each topic can be found in the description box below and the pinned comments. Physical property can be observed without changing the chemical identity of the substance. Chemical property, on the other hand, is observed after the chemical identity of the substance changed. So the main difference between physical and chemical property lies in the chemical identity of the substance, whether it changed or not. For most physical properties, we can further classify them as either intensive or extensive property. Intensive property is independent on the amount of substance, while extensive property is dependent on the amount of substance. To make it easier, we can classify whether a property is physical or chemical by asking a simple question: whether that property can be observed without changing the substance identity. If yes, then it's a physical property. If no, then it's a chemical property. To further classify physical property, we can ask if that property depends on the amount of the matter being measured. If yes, then it's an extensive property. If no, then it's an intensive property. Let's test out this flowchart using a few examples. Before we start, would you like to pause and give it a try on your own first? We can go through them together when you're ready. We'll start with the first one, heat of combustion. It's the amount of heat that's released when a substance is burned in oxygen. In order for us to measure the heat released, the substance will need to react with oxygen and form different substances. That means its chemical identity will definitely change, so that makes heat of combustion a chemical property. Next is volume. We can observe it without changing its chemical identity, so that makes it a physical property. If we have a lot of that substance, we say it has high volume, and if we have very little of it, then we say the volume is low. That means volume is dependent on the amount of substance, making it an extensive property. Color. It can be observed without making any change to the substance identity, therefore making it a physical property. Now, since we can observe the color regardless of the amount, that makes color an intensive property. Flammability is how easy something can catch on fire. In order for us to observe that, the substance will become something else when it catches on fire. That makes it a chemical property, since its chemical identity will change. Temperature of a substance in a reaction vessel can be measured without having the substance change its identity. That makes temperature a physical property. Now, if the content of the reaction vessel is split into two separate containers, the temperature in both the containers will be the same. That means temperature doesn't depend on the amount of substance, and that makes it an intensive property. Size is something that can be measured without changing the chemical nature of the substance. That makes it a physical property. If we have a lot of that substance, the size is large. If we have very little of it, the size is therefore small. Since it's dependent on the amount of substance, we say size is an extensive property. Mass of a substance can be measured without making any change to the substance. Therefore, it's a physical property. Now, if we measure the mass of a substance in a container, and then we split it into half, the mass of half the substance will be divided into two as well. That means mass is dependent on the amount of substance, making it an extensive property. Luster is how shiny or dull a substance is. We can observe that by looking at it without having the substance undergo any chemical change. Since that's the case, that means luster is a physical property. Let's take a sheet of aluminum foil, for example. It's shiny. If we were to tear the aluminum foil to a few pieces, each piece will be just as shiny. That means luster doesn't depend on the amount of the substance, making it an intensive property. Last but not least, reactivity. If a substance is reactive towards water, for example, it will react with water to form other substances. That means its chemical identity will definitely change. That makes it a chemical change. How did you do? Did you manage to classify all the 9 properties correctly? Here are 6 more for you to practice on. I'll place their answers in the description box below. Let's jump straight in with the definitions of physical change. It's a change that goes from one form to the other. It doesn't involve any change to the chemical identity, meaning its chemical composition. So it's still the same substance after the change. So the effect that we see is only on the physical properties. And generally, that change is easily reversible. So let me use an example to illustrate physical change. Melting of ice. So let's think of ice. Before melting, it's solid, H2O. After melting, it's liquid, H2O. In terms of its physical properties, it has changed from solid state to liquid state. But in terms of its chemical identity, or the chemical property, there was no change to it. It was H2O before melting, it's still H2O after melting. So there's no change in its chemical identity, meaning it's still the same substance. The only change that we notice is the effect on its physical properties, changing from solid state to liquid state. Also, we can easily reverse this process by simply taking the melted ice, which is the water, place it in the freezer, and it'll freeze again to become ice. So that basically illustrates physical change. Now we move on to chemical change. Chemical change is a little bit different from physical change. It's a change that's accompanied by a change in its chemical identity, meaning before and after the change, it is not the same substance. It forms new substance. And the effect that we see is going to be on both physical and chemical properties. And usually it's very difficult to reverse the change. So let me use an example, burning paper. So if you imagine before burning the paper, so you have a piece of paper, after you light it out, it burns, and it burns into ashes. So before burning, it was a piece of paper, solid, and after burning, it becomes a smaller piece of paper. So there's a change that we observe in its physical properties. In terms of its chemical properties, it changes its identity entirely. It was paper before burning, and then after that, it became ash after burning. Ash is not paper, it's a new substance. Also, I can't reverse the change, meaning I can't turn the ash back into paper. So that basically illustrates chemical change. Let's go through some of the things I did this morning and classify them as physical or chemical change. So the first thing I did this morning after waking up was brushing my teeth. Now my toothpaste has fluoride ion in it. So when I brush my teeth, the fluoride ion in the toothpaste changed the chemistry of my teeth. And what that did was it strengthened my teeth and helped prevent future cavities from forming. So technically speaking, that forms a new substance on my teeth. Also, that process is not reversible. So brushing teeth is a chemical change. After brushing my teeth, I hit the shower. Since it was a hot shower, steam started forming. So what happens when hot water changes to steam? Well, there's an obvious change in its physical properties, from liquid state to gas state. However, the chemical identity is still the same, it's still H2O. So steam forming in the shower is a physical change. After shower, I head down for breakfast, so I pull out an apple and washed it. Since after washing the apple, it didn't change to another fruit, it's therefore still the same substance. So washing apple is a physical change. Same thing goes to cutting the apple. It only changed in size and is still apple, so cutting apple is a physical change. Then I decided to fry an egg, because apple is just not enough. So the heat from the pan causes the structure of the protein in the egg to change permanently. That process is actually called protein denaturing. Since this change is not reversible and the protein structure of my egg has changed permanently, so frying an egg is a chemical change. Now I don't know about you, but my morning is not complete without coffee. So I grinded some coffee beans. Grinding coffee beans only involves change in its appearance, meaning it changed from whole beans to coffee grounds. Since after grinding it's still the same substance, which is coffee, it's therefore physical change. After grinding the beans, I brewed a cup of coffee. So what happened was there was a transfer of taste and smell from the coffee grounds to the hot water through an extraction, which is a chemical reaction. So that means my water was no longer just water. It became the elixir of life, which is coffee. So brewing coffee is a chemical change. While taking a sip of coffee, I accidentally spilled my coffee on the table. So I got a piece of paper towel from the kitchen
Tearing the paper towel from its holder only changed its appearance, from a roll of paper towel to a piece of paper towel. It's still the same paper towel. So that means tearing paper towel is a physical change. Then I used that piece of paper towel to wipe the coffee that I spilled. So after wiping, coffee was absorbed onto the paper towel. But the chemical identities of both my coffee and my paper towel remain the same. Paper towel is still paper towel, and the coffee is still coffee. It's just absorbed onto the paper towel. I can easily reverse this process. What I can do is I take my piece of paper towel that has coffee on it, soak it in water, take it out and let it dry. So I'll get back my paper towel and my coffee is left in that water, right? But of course I wouldn't drink that coffee anymore. Since it's reversible and the substances remain the same, therefore it's a physical change. Unfortunately, after breakfast, I had to wash my dishes. When I washed the dishes, a chemical reaction occurred between the detergent and the mess on the dishes. So that means the substance before and after washing are no longer the same. The dish detergent is no longer the same. The chemical makeup of the mess on my plate has changed as well. So washing dishes is a chemical change. Just to recap, here's what we have classified from what I've done this morning before recording this video. Like I've mentioned before, when classifying change is to ask whether a new substance was formed. If yes, then it's a chemical change. If no, then it's a physical change. First thing first, what is matter? It's the stuff that makes up all material things, and it takes up space and has mass. Now that we know what matter is, let's move on to see how it is classified. Matter can be split into two groups: substance and mixture. Substance is a pure matter. It has definite or fixed composition. That means you know exactly what it is made out of. You'll be able to provide the chemical formula for it. Mixture, just like what its name states, it's a mixture of two or more substances which are mixed physically. This means each of these substances will retain their identities, so they don't combine to become something else. This is really the key point here. Going back to substance, it can be further classified into element and compound. Element is the most elemental substance. It cannot be broken down further chemically. Compound, on the other hand, is made out of two or more elements which were combined chemically. Mixture can be classified into two categories: homogeneous mixture and heterogeneous mixture. Homogeneous mixture is mixed well. When you see homogeneous mixture, you only see one thing. Whereas for heterogeneous mixture, you can see the mixture is uneven. You see more than one thing. All this will become clearer when we discuss with examples. Just hang in there for a little bit. To simplify the classification of matter, we can ask simple questions that will help us classify the matter correctly. So when given a matter to classify, the first question we should ask is, does it have fixed composition? Meaning, do we know exactly what it is made out of? Are we able to provide the chemical formula for that matter? If yes, then that matter is a substance. Then we can further classify it by asking another question, which is, does it contain more than one type of atom? So the key point here to keep in mind is that we are asking whether it has more than one type. Type, not number of atom. If it has more than one type of atom, answer is yes, then it should be classified as compound. Otherwise, if it only has one type of atom, it should be classified as element. Now back to having fixed composition. So if it doesn't have a fixed composition, meaning we are not able to provide an exact chemical formula or exact composition for that matter, then it should be classified as a mixture. And then to further classify our mixture, we ask whether the composition is uniform. That means the whole thing, is it mixed really well, where you cannot differentiate one substance from another? If yes, then it's a homogeneous mixture. If it's not mixed well, then it's a heterogeneous mixture. So let's start with our first example, sodium, Na. So the first question we asked is, does it have fixed composition? Well, yes, the answer is yes, because we know that it is sodium. Well, sodium has a chemical symbol of Na, so our answer to this question is yes. So therefore, sodium is a substance. Now, if you need to further classify it beyond substance, then we would ask the next question, which is, does it contain more than one type of atom? So looking at the formula, it's only Na, so that's one type of atom. So the answer is no. Therefore, sodium is an element. Okay, let's move on with our second example. Salt, NaCl. So same question, does it have fixed composition? Yes, we know the chemical formula is NaCl, so it's a substance. And then we ask the next question, which is, does it contain more than one type of atom? Yes, because we have Na and Cl, that's two types of atom. So the answer is yes. So therefore, salt, NaCl, is a compound. Moving on, saline. Does it have a fixed composition? Well, saline is actually salt water. It's a combination of NaCl plus H2O. So there's no exact formula for salt water, meaning salt water that's prepared by one person will differ from another person. So the ratio of NaCl to H2O is not fixed. It varies from person to person or from salt water to salt water. So therefore, it doesn't have a fixed composition. So it's a mixture. Now, if we need to further classify this, then we ask the next question. Is the composition uniform? So look at that glass of salt water. Does it look like it's just one thing? Or does it look like it's a little bit different on the top or on the side or at the bottom of the glass? No, right? It looks exactly the same throughout. So the composition is uniform. So therefore, it's a homogeneous mixture. Last but not least, this is a combination of salt and sand mixed together. So does it have a fixed composition? Of course not, because we're not going to be able to tell how much salt is in there, how much sand is in there. We can't provide an exact percentage of the type of salt and the type of sand that's present in there. So therefore, it's a mixture. And then we ask the next question, which is the composition uniform? Is it mixed well? Well, look at it. Do you see like some specks of white color here and there, and then some darker specks here and there, and some lighter in between colors? It's not mixed really well, right? I mean, some parts has lighter color, some parts have darker color, so the composition is not uniform. Therefore, it's a heterogeneous mixture. Here's a summary of the flowchart that we can easily use to classify elements by asking simple questions.
Thanks for watching all the way till the end. Do subscribe, like, and share this video if you find it helpful. It'll help the channel grow, and I'll really appreciate it.